Hello, class. Moving on with chapter one, we are now in section 1.4, which is about rational expressions. Okay. And this is really kind of related to rational functions, which is an entire separate other section. But whenever you hear the word rational, like remember with the capital Q and the rational numbers, you should think about fraction. All right, that's really what math people mean when we say rational. So, rational expressions, okay, are basically fractions, okay, with polynomials, okay, as the numerator and the denominator. Okay. And so, just like quick examples. All right, like here, 2x over 2x minus 1, rational expression. X over x squared minus 1, rational expression. And then like they can even get horrifyingly long, like, this over 4x to the fourth minus 3x cubed plus 2, stuff like that. Okay, all rational expressions. But before we really get into rational expressions, I need to kind of crash course you on what is a domain. Okay. Now, domain used to be like the defining feature of between like an A student and a B student. Like if you understood domain very well, you would possibly be an A student, and if you didn't, then that would probably elude you. For now, I'm going to introduce kind of the two rules of domains. Okay. Rule one is you can't divide by zero. Okay, that is fundamentally what we watch out for. Okay, and then rule two is you can't have, all right, negative numbers in, and this is a big deal, even roots. Okay, you can't have negative numbers in even roots. And then again, like remember, square cube root of -8, that's -2. So again, odd roots, that's fine. Okay, it's only even roots where like, right, we get the square root of -2 doesn't exist, right? All right. So domains for the first part are kind of easy. So if I just give you like a polynomial, like 2x plus 3x plus 4, okay? This thing's domain is all real numbers, okay? Which we write in interval notation as -infinity to infinity, okay? And so for the most part, this should be your default answer. Okay. Most, like every polynomial has domain -infinity to infinity. And then later on, we'll find some other functions that are also the same. So this should be the default answer. It's only when these two rules might get broken that you have to start worrying about, is the domain not this? Okay. So, example 2. So here, I'm going to just have like 1 on top, something simple. And then x squared minus 5x plus 6. Okay, so remember, right, rule one is we can't divide by 0. So you kind of want to figure out when is the bottom 0. So I'm going to factor the bottom, and here's why knowing how to factor is important. So factor the bottom, and then, right, so then hopefully you can see, right, oh, if I plug in 2, this thing is 0, and that's bad. Okay, so x should not be the number 2. And then for the same reason, we see that if we plug in 3, that's also bad because then this parenthesis becomes 0. So we don't want 3. Okay? And so this is the answer. Okay, you should always write this down because you'll get 9 out of 10 points or 8 out of 10 points on a test question if you get this far. Okay, because this is the correct answer. It's just we always like to have our answers in interval notation, okay? Which is why I also said interval notation is very important when I introduced it. So you kind of want to figure out how to say this in interval notation. And here's where we're going to use the parenthesis, right? So how do you say x is not a number? Okay. In interval notation, that'll look like number, okay? Parenthesis, union, parenthesis, the same number, okay? And then like other stuff, right? This tells you this chunk here means not this number, okay? So we always start at negative infinity, and then I don't want 2, so I'm going to put 2 parenthesis union parenthesis 2. That means not 2. And then I'm fine, and then I'm going to go to 3, and I don't want 3, so I'm going to write that down. And then the rest of the numbers are fine, so I'm going to go off to infinity. And ta-da, this is the actual answer. Okay? So hopefully, I know it's like long looking, but hopefully you like recognize the pattern of how we say not a number. Okay? All right. And then now let me just add some stuff, okay? So an important note is it doesn't really matter what I make the top for the most part. Like I can ignore a lot of things. Okay, so there's like polynomial, and I'm gonna have x squared minus 1 here. Okay, when we're talking about domains, right, the domain of a polynomial is all real numbers. So really the top here doesn't matter. We don't care. So top, okay? The bottom we care about. So I'm going to factor this. This is a difference of squares. Hopefully you memorize that formula. Okay, so the domain of this is x not equal to 1 and negative 1. Okay, the top didn't matter. Okay, so final answer, let me do the negative infinity, negative 1. Infinity. Okay, now, so the top doesn't matter. Here's an example, and this is important. Example 4. Okay, here's an example of when the top actually matters. Okay, so here's this expression. Okay, we see that from the bottom, right, we don't want 5. Okay, hopefully we all understand. But now we have a square root, and that's an even root, right? So that's the other rule that we care about, is we can't have negative signs. So from the top, x should be positive, right? These are the two things I should get from this rational expression here. So I need to combine these, right? Or I need to find the intersection, which is not that hard, right? X greater than or equal to 0. That means this, but I just want to take out the 5. But I know how to take out numbers, right? It looks like this thing. So just, tweak this a little. And ta-da, here's the answer. Okay? So the only time the top actually matters is when you have square roots or fourth roots or anything like that. Way in the future, logs, but we're not there yet. Okay? Now, roots. Let's talk about roots because, okay, so the bottom, whenever you have stuff on the bottom, you're just going to factor, solve when it's 0, and then it's not going to be those numbers. For roots, you need positive numbers, right? So here, let's get an example 5. Let's do something a little easy, negative x. Okay? So how do you solve these is pretty simple. Okay? You're going to take whatever's inside, okay, the whole thing. So here, negative x. Okay? And you're just going to put greater than or equal to 0. Okay? So whatever's inside, you're going to put on the left-hand side and greater than or equal to 0, and then you're going to solve. So here it's easy. You want negative x to be greater than 0. So I'm going to multiply both sides by negative 1. And hopefully We're not there yet, but when you multiply both sides by negative numbers in an inequality, the sign flips. Okay, so this is a big deal. Flip. Okay, so you want x to be negative, right? So the domain is negative infinity to 0. Okay. And we see that this works, right? Like, let me just show you, right? So like if I plug in -4, what happens, right? You get the negatives that like cancel out. So you just get square root of 4, and that's 2. And you see, everything's fine, right? But as soon as I try and plug in like 1, well, right, that's a problem. You see? Okay, bad. So, domain. Okay. All right, now I'm going to show you a trick question. Okay. Or kind of tell you a rule. Okay. About domains and simplifying. Okay. And so the too lazy didn't read version is just don't simplify. Okay. All right, because like let's pretend. So I have a function. Okay. X squared minus 1, x squared plus x plus minus 2. Okay. So I'm going to factor the top and the bottom. Okay, so x minus 1, x plus 1. Okay, factor the bottom. Think about it for like 2 seconds. X minus, just kidding, x plus 2, x minus 1, okay? And then, right, so we see that, oh, look, we can cancel. So then this is equal to x minus 1, x plus 2. And then you might be tempted to be like, oh, the domain is just x not equal to 2, negative 2. Okay? But that's wrong. Okay? The domain of this thing, okay, the actual domain is x not equal to negative 2 and 1. Okay, you can't just cancel the, oh, I canceled the wrong thing. Huh, that looked weird. There you go. Okay. You can't just cancel the x minus 1. Okay, that's like not really allowed. Okay. And the reason is because if you plug it in before you canceled, right? Like if the question is find this thing's domain, and you plug in 1, you're still going to get 0 on the bottom here, right? 1 plus 1 is 2, 2 minus 2 is 0, okay? So basically the rule is find the domain, okay? If you are asked to find the domain, the rule is find the domain before you simplify. Okay? Not after, okay? Or at least you can simplify, like you can factor, but don't cancel. Find the domain before you start canceling things. All right? Okay. Now, moving on. Okay. Now actual, crash course over. Let's talk about rational expressions. Okay, so rational expressions, we need to know how to do stuff with them. Okay, so multiplying and dividing. Okay, so if you remember multiplication and division of fractions, like right from a couple sections ago, it worked like this, right? You just multiply across and you get that. It is actually the same thing. Okay, so if I just put ax, bx, dx, and cx, where all of these are polynomials, it's the same. You just multiply across. Okay, nothing extra complicated. All right. So let's do an example. So here I'm gonna have x squared plus 2x minus 3, x squared plus 8x plus 16. And I'm going to multiply this by 3x plus 12 all over x minus 1. Okay. So again, you just stick them next to each other. Okay. So x squared plus 2x minus 3, 3x plus 12, and then x squared plus 8x plus 16, and then x minus 1. Okay, so technically you're done. It's just this isn't simplified. Okay, like this is the answer, but now you have to simplify. Okay, so let's start factoring. Okay, so this factors, okay, into x plus 3, x minus 1, okay? And this thing factors, but like just take out the 3. Okay, so I'm going to remove the 3. I'm going to take it out. So x plus 4. Okay. Now this one also factors. Hopefully you recognize the formula, because that's the square of a binomial. So x plus 4 squared. Okay, I'm going to just write 2 of them because that's a little more normal. Okay, so x plus 4 times x plus 4. And this just is what it is. Okay. So you fully factor everything, okay? And then now you can start canceling. So we see that this x minus 1 cancels with this x minus 1. One of these can cancel with this. And then we get the actual answer. So 3x plus 3 over x plus 4. Okay. And then you can answer this. There's like multiple formats. You can put like the 3 in front like this. That means the same thing. I know a lot of students sometimes get confused. Okay. You can multiply in the 3 if you feel like it. That's a little weird, but that's okay. Okay. All of these acceptable final answers. Okay. All right. Now, but notice, okay, so notice I factored everything. A big deal is you should never FOIL, right? Like you don't want to FOIL these. Okay, that would just be a lot of pain for no reason. Okay, because then at the very end you'd want to simplify it and stuff would cancel. Okay. All right, so if multiplication is the same, I hope that you would guess division is also the same. Okay, so here I'm gonna have some polynomials and I'm gonna divide. Okay, x squared minus 3x minus 4, x squared plus 5x plus 6. Okay, so remember the keep, change, flip, or keep, change, change. So I'm going to keep the first rational expression the same. Okay, I'm going to change the division symbol to a multiplication symbol. Okay, and then I'm going to flip the other fraction. Okay. All right. And then we know that essentially this is the same. So I'm just going to cheat. I'm just going to move this close. Okay. Ta-da, I have multiplied. Okay. So now I just need to simplify. So I should just factor everything. So x minus 4 is stuck like that. This thing, okay. Hopefully you can see x plus 2, x plus 3, okay. This, that is x plus 2, x minus 2, okay. And then this one, does that factor? Yes, it does, okay. X minus 4, x plus 1. That one's a little weird, but that's okay. All right, so you fully factored this, and you could fully factor instantly, like the order in which you do this doesn't matter. Okay, if you like factoring at the start, go ahead. All right. But now I see all of these factors, and I just start canceling stuff. So those cancel. That's it. So the final answer is x plus 3, x minus 2, x plus 1. Okay. And I guess I should, box your answers preferably. All right. So this thing, this is kind of fake. First of all, you probably would never see it like this with this divide sign. Usually you, the student, are the one that puts this here. So this introduces kind of the next topic, okay, which is kind of called compound fractions, or fractions on fractions. Okay, so compound fractions. So here's a long example. Okay, so here I have some fractions. Okay, so this is a compound fraction, right? We see that there are two fractions here and a big fraction bar, okay? So if I wanted to make this look like the previous example, I would just do x minus y plus 1 divided by, because the big fraction bar will become the division symbol, 1 minus x plus 1. Okay. But we see that there's kind of a problem here, because the 1 and like the plus and minus kind of make it hard to flip. Okay. So what you really need to do first is make everything a fraction. Okay. So you kind of want to find like a least common denominator, or make these two things fractions before you do that. Okay, so I'm going to do it kind of the way everyone wants you to do it. Okay, so 1, right, is actually, or I guess I could multiply. You can multiply by y divided by y here, and you can multiply by x divided by x there. Okay, so that's going to equal x plus y over y, and x over x minus y over x. Okay, so you found the least common denominator, and now you're going to add them. So x plus y divided by y, and x minus y divided by x. And now you can do this division thing with the long fraction bar. So actually we're going to have x plus y divided by y, divide symbol, x minus y. Okay, and then now you can do keep, change, flip. So times y. And then you get your final answer. Okay, which I'm just going to write like this. Okay. There is no canceling. It is just stuck like this. So this is the final answer. Okay. Now, this is one way to do it. I think this is the way your book would teach you. Okay, you find the least common denominator of the top and the bottom, and then you make them big fractions, and then you simplify. Okay. I'm actually gonna give you another way to do it, just to give you options. Okay, so I'm gonna redo this problem. Okay. And instead of doing this tiny y over y, x over x, and then combining all of this, one thing you could do is, since here it's kind of easy, you can see that the common denominator of everything here, okay, would be like, what if I multiply the top and the bottom of the big fraction by xy? Okay. Well, then you distribute everything. Okay. The y's would cancel, right? So I guess I should show some more. So x, right? You see how these would cancel? And the 1 would just be xy. Xy minus, then yxy over x. Okay. So if you simplify a little bit, you're going to get x squared plus xy over xy minus y squared. Okay, and then just to kind of show you something, like, right, I can factor an x from the top and a y from the bottom. X plus y, y, x minus y. Okay, and you see it's the same. Okay, so whatever style you like, go ahead, pick it. All right, you get the same answer. It's fine. Okay. But yeah, so this is kind of how you deal with compound fractions, is you either like simplify top and the bottom and then deal with the big fraction, or you can kind of like multiply by like the big common denominator. But then you might have to simplify at the end. Okay, so personal preference. Okay. Now, let's deal with some more questions that you could kind of see on like a test. Okay. So a lot of questions, maybe like 3 or 4 questions on your test one, will just give you the instructions to simplify. Okay. And so here's something that you could see. So x squared plus 1 to the 1/2 power minus x squared, 1 plus x squared, negative 1/2 power, 1 plus x squared. Okay. Now, this might look simple to you guys, but when we mean simplify, that always means no negative exponents, okay? And then so if we fix that, right, if we deal with this negative exponent, we can see that we actually have x squared plus 1 to the 1/2 minus. And then so, right, remember that negative exponents, they just mean flip. So x squared 1 plus x squared to the positive 1/2 all over this thing. Okay. So we're here. Now, this isn't as bad as this previous example, if you think about it, because here we had like 2 fractions. Here it's just this thing. So what you could do, and it's probably what I would do, is just multiply by the denominator. Okay. So I'm going to multiply the top and the bottom by this thing. Okay. So you have to distribute. Okay. But okay, so notice that these are the same. So you add the powers. Okay, so 1/2 plus 1/2 equals 1. Okay. Here would just cancel, so you just get x squared. And here, right, so this is a 1 power. So 1 plus 1/2 gets you 3/2. Okay. And then so this is 1, right? So really the top is just x squared plus 1 minus x squared over this thing, x squared plus 1 3/2. Notice the x squareds cancel. So the final answer is x squared 1 over x squared plus 1 to the 3/2. Okay. And if you wanted to, you can like square root x squared plus 1 cubed. Both of these red expressions are good as final answers, right? Whatever you want. But yeah. This is what we mean mostly by simplify, is that you should get rid of negative exponents and no compound fractions, okay? And then obviously if like you see like 2 plus 2, make it 4, right? Like do the simple math first, okay? Now, your textbook has like this table, okay, of common mistakes. Common mistakes, okay? So I kind of want to talk about a few of them, all right? Let's remember, okay, that if we have two things in a parenthesis like this, multiplied, you can distribute the power, okay? This is okay. Check, right? The common mistake is if you have a plus sign, okay, that you break it like this. This is the 100% do not do. This is bad, okay? Not only is it bad, but it's also every math professor's pet peeve. So it's like bad and also will make your teacher angry, okay? So it's very bad, okay? Now, another thing that we do is, right, if we have x plus y over 2 or something, we can split the denominator like this, okay? Right, because this is how we add. Normally we go this way, right? But you can also go the other way, because that's how equal signs work, right? You can go forwards and backwards. This is okay. That's good, all right? The common mistake version is if I try to do the opposite thing. Okay, if I have like a 2 and then an x plus a y, you go like 2x plus 2y. Okay? This is also very bad. All right, this is understandable though. So no professor gets mad here. But no, it doesn't work that way, right? And if you just look at it the other direction, it's obvious. Because right, you need common denominators. Okay, so it should be like it's like completely wrong. It's like very, very wrong. Okay. Okay. So those are just the two common mistakes I would like to talk about. You can go into the notes folder and like read 4.1, and there's like a little table at the end if you want to see all of the common mistakes. But these are the two big ones that I wanted to like explain and make sure you guys do not do. Okay. All right. And that's it for section 1.4. All right. See you guys next class.